thank you very much for being here and coming to see my talk about a program that I call Manalyze. So it's a static analyzer for PE executables. So first, I would like to say a few words about who I am. So I work for a Paris-based company called ACMS International, and I'm really not going to go on too long about what we do. Basically, just run-of-the-mill security stuff, services, etc. We are a two-man team. I work with @Xors, which you probably already follow on Twitter. Since we're a very small company, we do get a lot of leeway to work on some open source projects. We release a lot of code on GitHub. So other projects I've worked on are APK Track, which is an Android app to track updates for Android software for people who don't have the Play Store or do not want to use any Google services like I do. There's also maybe something that's going to be more relevant to your interests, which is what I call freedom fighting. It's a repository for pen testing scripts. It contains something like a stealthy log cleaner, a reverse encrypted Python shell that also supports TTYs, so stuff geared towards red teaming. Apart from that, I do operate a Tor exit node. It's located in France, and I've learned yesterday that a French exit node operator has just been not arrested, but he's been questioned by the police because his exit node had been used to access some kind of child pornography case. I don't know, so this might be my last talk ever before I go to jail as well. Hopefully not. And finally, I'm not CISSP, which is currently some kind of running joke on Twitter, so I thought I'd just mention it. So a few words about the project origins. So Manalyze stands for malware and analyze. I learned at a later date that in English it has also a whole different meaning, which I didn't know about, but the project was already named this way, so I didn't want to change it again. I started working on this in February 2014 when I was working at a security operations center. There were mainly two reasons for my starting this project. First was my personal annoyance and frustration at antivirus software's opaque decisions. What I mean by that is that I used to have hard drives full with malware samples that I downloaded here and there over the whole wide web, and regularly that every time I would plug the disk, I would be very fearful that the antivirus software would try to delete everything on it, and it was very annoying. At the same time, every time I would download the program from the internet, sometimes it would get deleted, and I wouldn't have any explanation as to why the program was flagged as being suspicious, and it was kind of frustrating. So imagine you're downloading a keygen for a $1 application, that keygen that you've tracked for maybe an hour of your life that you're never getting back, and as soon as you've gotten your hands on it, it just gets deleted with no form of explanation. I just wanted to know what were the reasons behind my antivirus software decisions. So there was also another concern that I had in my job was that a lot of the tasks that I had to do were increasingly growing repetitive. So every time I would receive a malware sample, I would first drag the sample into PEID to see if there was a known packer. I would then upload the file to VirusTotal, etc., etc. So I was wondering, why can't there be a single tool that does all this? And as I couldn't find any, I just decided to write one. So just to give you a quick overview of the project, it's free open source software, so it's released under the terms of the GPL v3. It's a tool that was written in C++, and it's available on both Windows, Linux, and I think it probably works on Mac OS as well, even though I've never tested it. What it's used for is to perform initial assessment of PE files. So the objective is to be able to quickly figure out whether one sample is worth investigating closer or whether it's like a known quantity that you can discard almost immediately. So the way it works is it's going to generate a report containing weak signals that hint at the file's behavior. And I would like to point out immediately that the way it works is it's not a drop-in AV replacement. It's definitely not some program that you're going to be able to give to your end users and expect them to be able to take decisions based on what the program outputs. It's developed for InfoSec professionals, and it's not a replacement for human intelligence either. So what it does is it gathers as much information as it can on a particular file and presents that information to you, and it expects the user, the expert user, to be able to understand this information and be able to take a decision based on whatever was collected. So it shows you a lot of information, and you figure out whether you want to open the file in IDA or drag it into the Kirku sandbox, etc. This morning, we've had a very interesting talk from Ed about dynamic analysis. I don't want to go into too much details about the differences between static and dynamic analysis. I'm sure most of you have already some experience in the field. So the only thing I'm going to say is that static analysis has its shortcomings, but it also yields very quick wins from time to time. So I think it would be a shame not to take 20 seconds to look at the outside characteristics of a program and see if we can already infer its behavior just from there. So the tool only performs static analysis and does not do any sort of dynamic execution, or not even symbolic execution. It's just looking at the way the file is structured and trying to guess what it does from there. But the architecture of the program, so the idea is simple. You get a lot of input files, maybe thousands or hundreds of thousands of different files that you know nothing about, and you feed them into a PE parser. The PE parser is going to dissect the file and offer all the information about the file to a whole set of plugins that I'm going to go into much more details later. And each of this plugin is going to generate some individual output that populates a report in the end. I also embedded the Yarra engine, which I think most of you know as well, that can be used by the plugins to perform additional tasks. And finally, after the report has been generated, it goes in an output formatter, which is going to format the text into either plain text for your human readable output or JSON for other tools if you need to use them. So the way this talk is structured is I'm going to go over each different parts of this architecture to talk about the different reasons and technological choices that I've made developing this tool. So the first and core part of this program is the PE parser. So before starting to work on this project, I looked at the different PE parsers that were already developed and that I could reuse. So I looked particularly into a PE file in Python, and there were also a couple of C++ libraries, but all of those were ultimately rejected. PE file was, I thought, a bit too slow, and I wanted to be able to scale a lot and handle thousands of files in a matter of minutes. So this is why I didn't want to go to the Python way. And the C++ libs I found looked like they were very unsafely written, and I didn't want to risk using them. So I decided to write my own, which might be a bad idea. You let me know. The problem is that PE files are extremely complex. So there is an official specifications for PE files. You can download it from Microsoft's website, but the thing is, this specification is sometimes quite cryptic, it's not very clear, and moreover, the Windows as a loader that actually parses the PE files for the OS is quite lax. So it's going to accept a lot of files that do not adhere strictly to the specification. And writing a parser that performs strict parsing is going to reject a lot of malware that would actually be able to execute on a normal system. So there are also there's another difficulty is that since we are going to be handling malware, which is by definition a very interesting input, we know that there is a significant chance that the input that we're going to use is going to try to actively attack the parser. So there have been a couple of bugs in IDA Pro in the past that, and other analysis tools that were just attacked by the malware in order to prevent analysts from reversing the programs and looking into it. So there is a very nice presentation from Black Hat US 2011 where people from reversing labs discussed all the different pitfalls that they had identified while looking at the PE specification and the way they could maybe crash analysis tools. So yeah, the idea is that I wrote my own PE parser. I did it in C++ as well, so you're probably thinking that this is a very stupid idea because C++ is a memory unsafe language. All I can say is that C++ is fast, and I did my best to program very defensively. I also tried fuzzing the programs for maybe something like 2 months with AFL, a well-known fuzzing tool from Google. Didn't find any crashes. I used Ange Albertini's handcrafted PE file. So he wrote minimalistic PE samples that do work on Windows, but are not exactly valid as well. all I can say is I couldn't find a lot of crashes. Well, I couldn't find any crashes at all in the program. I opened a bug bounty. So if anyone can find a PE executable that triggers a crash in my parser, feel free to send it to me, and there's a bug bounty on it. It's not a lot, but it does come out of my personal pocket money, so please be understanding. Oh, what's going on? Nice. There's a PowerPoint crash. I'll have to investigate that later, probably. Or, no, it still works. The VM is shutting off. That's nice. OK. Please bear with me for a second. Oh, this is awkward. Yeah, and of course, there's Windows updates as well. That's just been triggered. OK. I'll do my best to continue without the slides while everything is rebooting. So there has been a Chinese researcher who's been fuzzing the application as well. He's found 2 crashes in the past, so it's definitely not foolproof. But I mean, yeah, please try to find the bugs in the application. Maybe you'll get the rewards as well. So hopefully, it won't be too easy. Damn it. I'm so sorry about this. Yeah. So we're back. Yeah, so finally, I talked about the speed. I was able to go through a whole virus share release with the tool and was able to go through it in about 10 minutes. So parsing about 68 gigs of executables in a few minutes. I think it's quite nice. The caveat is that a lot of the files in the virus share archives are actually not PE executables, so they just get rejected as soon as the analysis starts. Another thing is that all the analysis plugins were turned off, so obviously this speeds up analysis a bit. So a few words about Yarra, which is a pattern searching tool written by Victor Alvarez from VirusTotal. You all know about Yarra. All I'm going to say is I use a slightly modified version in Manalyze. The reason I do this is that they have their own PE parser to do stuff like looking for patterns at the entry point or looking for patterns at the specific section. And it felt really bad having 2 different PE parsers in the same project. Even having one is already quite shaky to me. So I removed the parser entirely and put mine in their place. I added C++ wrappers as well and removed all the non-library code. Now I'm going to talk a bit about all the different plugins that I implemented inside this tool. So the first one is ClamAV. What I do is I simply apply ClamAV signatures. ClamAV doesn't need to be installed on the machine. All you have to do is download signature files, run a Python script that converts them into Yarra rules, and then apply those Yarra rules automatically with the program. So the signatures are not distributed with Manalyze because obviously they change every day, but there is a Python script that just allows you to download them and use them immediately. They also have, ClamAV uses other kinds of databases that are HDB and MDB files that are just big lists of hashes of known executables and sections that I don't use, but maybe I will at some point. I also have a resource analysis plugin, which looks at resources are mechanisms that are used by PE files to embark arbitrary contents. So looking at those resources usually leads useful information. It's mechanisms that malware is liable to use to drop other executables or files that they might be needing to use, like configuration files, etc. So just by looking at the resources of a PE file, like are they possibly encrypted or compressed, is the PE file composed of more than 75% resources, etc., in which case we might infer that this is maybe a dropper, we can get some interesting information about what the PE might be doing on the machine. So of course, if you use the program called a resource hacker that works only on Windows as far as I know, you can use Manalyze to extract resources on any OS. I also have a PEID plugin, which just applies PEID signatures. Yeah, I've decided to spread them into two different plugins. One that's dedicated to compiler detection, and the other one to packer detection. The packer detection plugins also looks for well-known section names. So if if there's a section called .vmprotect, we know that the packer is possibly vmprotect, etc. So it's useful information. PID hasn't been maintained for, I think, a few years, so I'm not sure how relevant their signatures still are, but maybe I'll just remove them at some point. So far, I haven't had any complaints. I have a strings plugin, which does the very straightforward thing of looking for well-known strings that indicate possible malicious behavior, like reference to system tools, like regedit, task manager, etc., etc. Debugger and process names, references to registry keys, the WMI. There are also a lot of virtual machine detection techniques that rely on looking for specific strings in the OS. So if you look for those strings in the malware as well, if the strings are not obfuscated, you're going to know immediately that it's trying to do something fishy. Basically, every time there is a new APT report that comes out, I browse through it, look for groundbreaking new evasion techniques, and add a few lines to this plugin to possibly detect new implementations. I also have a cryptography detection plugin that is directly inspired from the IDA Pro plugin of FineCrypt, I think. So what it does is it looks for the particular cryptographic constants used in particular algorithms. I also look for the OIDs that are used to reference other algorithms in third-party APIs. The way I did this was simply to download some random crypto library on the internet. I looked for all arrays of integers like this. I'm not sure if you can read it properly from where you stand. But yeah, the idea is I built some big Yarra rules that look for all those constants. And now I'm able to detect MD5, SHA-1, etc., AES inside binaries. So knowing that a binary is using cryptography is always something interesting because it can either mean that there is some obfuscation going on or even that the program is ransomware. We'll see some examples later. I also have a packer detection plugin, which I mentioned a bit earlier. There's a whitelist of section names. I look for possibly encrypted or writable and executable sections. I look that the number of imports is reasonable, so PE files that have less than 10 imports are usually a bit suspicious and require further inspection. Apart from that, there are also funny inconsistencies that are caused by some packers. So this is a funny one that I discovered a while ago. There was this packer that would compress every resource in the program, but it wouldn't update the size of the resources inside the PE headers. So if you were to sum all the sizes of all the different resources, you would end up with a size bigger than the size of the PE itself. So you would immediately know that the file has been packed. Something not groundbreaking, but it's always nice to have is import analysis plugin. So I'm going to look for combinations of imports that would hint at the program's behavior. So for instance, everyone knows about the virtual log, write process memory, and create remote thread that's used to inject code in remote processes. I look for networking functions, process service, and registry manipulation APIs. And also imports that can be used for code injection, in particular process hollowing, power loader, and atom bombing, which are well-known techniques to perform code injection, but all rely on very specific sets of APIs. There is a small example given here at the end of this slide. Again, I'm not sure if you can read, but basically this is a program that imports create process, shall execute, and also create file and get temp path. So it doesn't require a lot of thinking to figure out that this is a program that probably creates a file in the temp folder and tries to execute it. So most likely dropper behavior. One of the future works I'd like to work on is being able to resolve imports that are loaded dynamically with getproc address and load library with Capstone engine. I don't know if that's possible, but I'd like to try. One of the most recent additions is the Bitcoin plugin. So it just looks for Bitcoin addresses in a binary. So what it does is go through all the possible addresses and then tries to validate them. Bitcoin addresses have a very specific structure. The first 4 bytes, I think, from memory, are the SHA-256 of the rest of the address. So it's quite easy to figure out whether the address is actually a valid Bitcoin address or not. So this is the output of the tool for the WannaCry ransomware. So you can see immediately that even though it pretends to come from Microsoft Corporation, it contains 3 different Bitcoin addresses. And if you were to Google those Bitcoin addresses, you would find reports linked to the WannaCry attacks immediately. So this is this is a way to gain time and perform the analysis very, very quickly. Finally, I have this Authentical plugin that checks whether the digital signatures of the PE is valid. If I ever find a binary that's claiming to come from Adobe, Oracle, or Google, and if it's not signed, then immediately I can raise an alert and say that, okay, wait a second, this is supposed to come from a well-known publisher, but there is no digital signature, what's up with that? So far, the plugin is mostly only available in Windows. I have a Unix version that works, but it relies on OpenSSL, which is horrible to work with. On Linux, so I can display the certificate issuer, but I cannot check the digital signature at the moment. So there are other problems. So how do we check the digital signature of a program on Linux when you don't have Windows as trust store? There is another issue, which is Microsoft executables are often known by hash in the security catalog of the OS, and they are not even signed themselves. So is there a way I can export that into the tool? I have no idea. Finally, there's a VirusTotal plugin that just submits the hash to VirusTotal and returns any result. So all I can say is only the file hash is submitted if some of you are very privacy conscious. And you do need to register on virustotal.com if you want to use this plugin, because they won't let you use the API without a key. By the way, each plugin that I presented is absolutely optional, so you don't have to use one of them if you don't like it. Especially if you don't want to send queries to VirusTotal, you really don't have to. Finally, I created a portal, which is an online portal for people who want to try out the tool. So you can just submit executables online, or either the PE file directly or a link to it, and you will get the report immediately. The samples are not shared with anyone. I'm the only one with access to the server, but basically you really don't have to trust me if you don't want to. You can just download the source code from GitHub and run it locally. So I'm just going to give you a quick look at how this looks like. So here you've got the summary, the plugin output. This is still the WannaCry ransomware. So there are strings related to AES, CRC32, Bitcoin addresses in it, a few imports that are quite suspicious, etc., etc., and also the VirusTotal score, which is 58 out of 62, which is a lot. There's a tab for discussions if you want to share your findings, and then the whole PE structure, but I'm not going to go over that because it's more specialized. One thing that I'm quite proud of with this tool is that it's quite easy to use and reuse. So there's one thing I hate more than anything is when I try to use an open source tool and see that it's a mess to compile. I can't get it to work, that dependencies are missing. So I really did my best to make Manalyze very easy to install and use. So just apt-get install the dependencies, git clone the code from GitHub, cmake, make, and that's it, it works. You don't have, if you want to extend the tool, you don't need to understand the core. You can just use the API, which is, I think, quite well documented, and just interact with the PE parser without having to understand the structure beneath it. You can also use the PE parser and take it out of the project and use it in your own. One of the examples I made available online is using this PE parser to write your own process hollowing code. So you can find all the resources on my blog. A few words about the future works. So the things I would like to do most is getting that Authentical plugin to work on Unix. I would like to work on icon recognition. So if, for instance, an executable file has a PDF document icon, I think this is something we can detect automatically and raise alerts for very quickly. I mentioned wanting to use Capstone Engine to resolve imports. And as for the web portal, I would love to be able to work a bit on some more bigger data capabilities, like having a search engine, letting people search for malware based on section names or any characteristics you want. And finally, possibly Python bindings in the future. I've started working on this, but it's far from ready yet. Then I'm just going to do a short demonstration of the tool to illustrate how it can help people during their analysis. So this is a sample coming from the APT1 Siesta campaign from 2014. It's quite old, but I really like this example because it just works perfectly. It's not always the case. I have to be honest about this, but when it works, it's really, really nice. So let me launch just a full analysis of this program. And then I'm just going to launch all the plugins. I hope it's going to go. Yeah, there we go. So I have to go up a bit. So here we see the compilation date, which was when we received the file in the SOC I worked at. It was somewhere around January 17th, so we knew it was a very fresh strain. There was references to the Chinese language inside the PE file. At the time, there weren't any ClamAV signatures, but there is now. So we see here that it's creating processes and creating files in the temporary folder. Yeah, this is possibly a dropper because when you look at the resources, then one of the resources is a PDF document, which is weird. Why would a PE file embark in a PDF file? Who knows? There's also another P executable embarked inside the file, and all in all, the resources amount for 93% of the executable, so mostly this is a file whose only role is to drop other files. Yeah, constants related to this as well, so there was a strings obfuscation being performed, and now there are lots of different signatures by antivirus software. So what we can do from there is extract all the resources to look at them closer. I create a folder called out. So there we go again. So I'm going to go to browse the folder and look at what's inside it. Yeah, so there's the out folder. So what's in there is a PDF document, the icon of the PE file, which is a PDF icon. This PDF was simply a decoy document that would be opened when the user clicked on the file to make them believe that they had, opened an actual PDF document that just didn't work. And here there was a second executable which was dropped on the system and we assume executed. So I'm going to perform the analysis on this second program. 09. Now go. And see here we see so there the reference to the Chinese language are not present anymore. There are still constants related to this, and now the interesting imports of this program are create process, internet open URL, etc. So we can easily infer that the first part was the dropper, and the second part is actually the implant that's going to perform download and execute, or that's going to be looking for commands on a remote server and just executing them. And oh, where am I going? And also a lot of signatures. So that's it for the example. One last thing I would like to mention is if you want to look at the PE structure in more details, you can just dump any part of the structure you want. So there you go. You have all the imports, the different sections, etc., etc. And if there is any part of this that you want to reuse in another tool, you can just use the JSON output format. Yeah, nice. And there, and you can feed it to another tool if you like. So I think that's it. I'll be happy to answer any questions. Otherwise, the project is available on GitHub, and feel free to download it, tweak it, and send me bug reports. Thank you very much. I haven't counted them. I think it's something like 2 or 3 gigs of files. But that's not much, but I only keep executables. I reject everything else. I think most people are not really interested in using the portal for anything else than just testing the tool. So people will upload 1 or 2 files to see how it works and whether it's interesting, and then if they are satisfied with it, I assume they just download the code and run it locally, because then they don't have to send me anything, which is perfectly okay as far as I'm concerned. Anyone else? Yeah?
Is it easy to make a plugin for it?
Yeah, it's quite easy in the sense that I've written a lot of documentation. There are a lot of, well, maybe not a lot of sample plugins, but all the code of the other plugins is, I think, mostly clear. There is one example, and then you can use the other plugins as a reference. So hopefully, it should be quite easy for you. But if you ever encounter any problems, then it means I have done my job wrong, and the documentation is not good enough. So be sure to let me know. You have to subclass a class and then implement a single method. And then you can interact with the p-parser through the API, but that's it. You just have to implement a single method, well, maybe 2 or 3 methods, because you have to provide the plugin name. Apart from this, you just drop in your plugin inside the program folder. Just drop the SO or DLL file inside the same folder as Manalyze, and it's just going to be detected and reused automatically. Okay, well, thank you very much for your attention.